Alrighty, folks. So we've got a digital lab today. Basically, you're going to use this link right here. I posted it in Google Classroom, and it pulls up our astronaut friend here. So if you've ever seen the movie Wall-E, there's a point in the movie where the robot uses a fire extinguisher. He uses it to kind of guide himself as he travels through space. We're going to do the same thing with our astronaut. So if I were to click Activate here, and then shut off. My astronaut's going to continue at the same velocity and then goes through these two red lines. Just like when we do our physical labs, these are photo gates. So basically, this is saying that it took 0.791 seconds for our astronaut to travel from this photo gate to this photo gate. And I can solve for the velocity just by saying my distance, 10 meters, divided by my time, 0.791. Down here is the force time. Basically, it's how long did we have the fire extinguisher firing for. Because I click shut off, it comes down, and it was firing for 2.89 seconds. We can also change around the extinguisher force, so I can make it less forceful, where I'm not going to have as great of a force impact. Shut that off, and it continues. Or I can change the mass of the astronaut. Okay, so if I click activate here, really not seeing a whole lot of a change in momentum based off of that change in mass. So we're going to do three experiments today. We're going to do the first one, which is how does increasing the force impact Wally's speed and momentum? How does increasing Wally's mass impact Wally's speed and momentum? And how does increasing time impact Wally's speed and momentum? So the very first one, I'm going to set my astronaut to have a mass of 35 kilograms. And I'm going to have my first trial be at 130 newtons. And I'm going to try to have my extinguisher activate for about 3 seconds. If you're not exactly 3 seconds, that's totally fine, not a big deal. But I'm going to click activate here. 1,000, 2,000, 3,000 off. So I was 3.369 seconds, and then it goes through my force gate. So for my actual force time, I would put 3.369. And for my photo gate time, I would put 0.799. Then I'm going to come over to my calculate section. I'm going to find my final velocity by doing 10 meters divided by 0.799. And that's going to give me 10 divided by 0.799 is 12.52 meters per second. Then I would do my change in momentum, which is going to be my mass times my change in velocity. So it'd be that number, 12.52 times my mass of 35. And that gives me a change in momentum of 438 kilogram meters per second. And then I'm going to do the same thing with my impulse using the force of the extinguisher, which in this case was 130, times the time, my actual force time. That's important, not the goal one. So it would be 130 newtons times 3.369. And that gives me 437.97 Newton seconds. And you'll notice that these two numbers should be really close together, right? So showing that the change in momentum is equal to the impulse. It just depends on how we're going to calculate one or the other. Remember, fat math, they're equal to each other. For our second experiment, you'll iterate this again, and the only thing you will change is the extinguisher force. So each time you'll just change your extinguisher force to be a little bit stronger. For experiment two, we're going to increase the mass. So we're going to set our extinguisher force all the way up to 200. We're going to start with a mass of 35, and we're going to try to do our goal force time of 3 seconds. 1,000, 2,000, 3,000, shut it off. Goes through there, and I'll record my numbers. So the actual force time was 3.21. My photo gate time was 0.545, and then I'll do the same calculations that I just did. And then our final experiment is how does increasing the time impact Wally speed? So we're going to set our mass to be 35 kilograms, our extinguisher force to be 200, but now I'm only going to do it for 1 second and stop. And it may take Wally a little bit longer to get through here. So we would expect that he's moving at a lower speed, so his velocity is going to be lower. So he hits there, boom, and boom. So the actual time that I launched him was 1.075 seconds. That's how long the extinguisher was going. And then the photo gate time was 1.628. And I would solve for my final velocity, my change in momentum, and my impulse. And then the next time I'm going to try to do it for 1.5 seconds. So reset, activate, one, boom. So I was a little bit off there, 1.727, and that's totally fine. My photo gate time was a little bit faster, 1.013. So you can see that as we increase the force, or the time that it is going to be launching him, it's going to increase the velocity as well. On the second page, you're only going to use experiment three's data, and you're going to go through and you're going to graph a force time graph, a velocity time graph, and a momentum time graph. And it's going to ask you, what does the area under the force time graph represent? Well, this is newtons times seconds. So it would be whatever that unit would represent, newtons times a second. Then it says, what does the slope of the velocity versus time graph? So it'd be meters per second over a second. So that's going to be meters per second squared. What does that represent? And then what does the slope of the momentum time graph represent? So this would be kilogram meters per second over a second. So that would be kilogram meters per second squared. What does that represent? And then finally, you're going to calculate the slope of that momentum time graph. And if you double the firing time, keep the force constant, what should happen to your final momentum? Does your experiment 2 data support that? And then you'll finish up with these conclusion questions down here. If you need anything, let me know. I'm still at school today. I'm just down at the pool. Good luck. This is going to be due on Monday.